Alright, so there are three methods to answer questions that deal with chance. The first is to actually carry out an experiment and calculate results of relative frequency. This is often impractical and time-consuming, so we don't do that often. The second way is to develop a probability model and use it to calculate a theoretical answer, but you have to know something about probability, and it's often unfeasible. The third is to start with a model that reflects the truth about the experiment, develop a procedure to imitate or simulate a number of repetitions of the experiment. And this way we would do it using either a random generator from the calculator or a random digits table.
How to conduct a simulation. So starting off, simulations are only useful if they mirror real-world outcomes. So here are the steps to do a simulation. Number one, you want to describe the possible outcomes. So if there are two outcomes, you want to state them. So if you're flipping a coin, you would say the first outcome is heads and the second outcome is tails. The second step is to link each outcome to one or more random numbers. So heads would be 00 to 49, and tails would be 50 to 99. The third is to choose a source of random numbers. You can do the random number generator on your calculator, find one on the computer, or use the random digit table. 4, you want to choose a random number. So you either press enter on the calculator and calculate numbers, or you go through the random table and find some. Number 5 is, based on the random numbers, you note the simulated outcome. So if you get more numbers from 0 to 49 than from 50 to 99, then the outcome is more towards heads. You want to repeat the steps 4 and 5 multiple times until you notice a pattern, until you can actually come to a conclusion. And 7, you want to analyze the outcomes and report the results. These steps will help you solve a simulation.
Okay, so a simulation is a way to model random events such as that simulated outcomes closely match a real-world example. So a real-world example would be we would use a coin and use heads or tails to determine whether you'd have a boy or a girl, so the outcome would be 50-50. By observing simulations, researchers can gain an insight on the real world.
Here's a problem of a simulation. On average, suppose a baseball player hits a home run once in every 10 times at bat, and suppose he gets exactly 2 at-bats in every game. Using a simulation, estimate the likelihood that the player will hit 2 home runs in a single game. To start out for step 1, you want to describe the possible outcomes. For this problem, there are 2 outcomes. The player either hits a home run or he doesn't. So step 2, you want to link each outcome to one or more random numbers. Since the player hits a home run in 10% of his at-bats, 10% of the random number should represent a home run. For this problem, let's just say that 0 represents a home run and the numbers 1 to 9 represents no home run. Step 3, we want to choose a source of random numbers to produce a list of 50 random numbers, and we're choosing 50 because that's a large sample size or experimental size that we can do to come up with a good results for our simulation. We can use a computer random generator, the calculator random generator, or we can also use a random digits table. So step 4, you want to choose a random number. So our number representing home runs is 0, and 1 to 9 represents no home runs. We're going to calculate the number of no home runs versus home runs 50 times. So you want to go to Menu, Run Matrix, Options, tab over to Probability, click on Random Integer, and you'll type in the starting number, the ending number, and how many times you want to do it. So we're going to start with 0, and then 9, and we're going to do it 50 times. And we actually want to tab over this little arrow, and we want to store it in list 1. And then you press enter, and here in our list, you can see all of the random numbers that were generated. So after you go through this, you will calculate how many numbers we have and how many zeros we have to find out the probability.
Okay.
You can also use the table of random digits. You would do this by, so here's the lines. Over here, you would just not look at that. And you would go through, you can choose a random line. So I'm going to choose line 118. And we want to do it 50 times. So we're looking at this, and here's 7, so that's a no home run. 3 is a no home run. 1 is a no home run. 9 is a no home run. 0 is a home run. So you would just keep on going through this and count how many zeros you have to calculate how many home runs you would get. So step 5, we're going to say based on the random number, note the simulated outcome. So when we did it in our calculator, we're going to go off those results. We we found that there were 9 zeros out of 50. So that means that he got 9 home runs out of 50 tries. So step 6, you want to repeat step 4 and 5 multiple times. So maybe since we only did 50, you can do about 8 or 9 more simulations so you can actually see a big pattern or a normal pattern. That way we have a lot more tests and we can have a lot more data that's more accurate, because the more tests that you do and you average them together, the more accurate the data will be. So on step number 7, you want to analyze the simulated data. So we repeated the experiment multiple times, and we actually just did the random number generator on the calculator, and we got 49 zeros out of 500. So that's just about 10% home runs, just like the problem told us. So to answer the actual question, it actually asked if you will have 2 consecutive home runs in one game. And to find this out, you're going to look through your random number generator and your calculator, and you want to find 2 zeros next to each other. So out of 500, we found 5 zeros that were consecutive. So 5 out of 500 is the chance that you will get 2 home runs in one game. The simulation suggests that there is a 0.01% chance that he will hit 2 home runs in a single game. The actual probability, based on the multiplication rule, states that there is a 1% chance that this player will hit consecutive home runs in a game. While the simulation is not exact, it is very close. If we had generated a list with more random numbers, it would have been even closer.